Hi boys and girls, I am Dr. Seal. I'm going to help you to prepare for your, this is the final examination, right? So I'm going to upload videos for all the question papers, 2024 November paper 1, 2025 June paper 1, also 2023 November paper 1, 2022, 2021, 2020, up to 2018. I'm going to upload both November question papers and June question papers. So you are supposed to subscribe to my YouTube channel in order for you to get the latest information. So today we are going to revise this 2024 November paper 1 ZIMSEC, whereby question number 1 is saying simplify x to the power 2, which is raised to the power 1 by 3 times x to the power minus 1 by 2 to the power 3. Everything divided by x to the power negative 1 by 6 times x to the power negative 2 by 3. So this is 4 marks. Okay. So if you check, you are supposed to simplify this. This is the question. This question is very simple. This is O-level stuff. You are supposed to apply the laws of indices. Okay. We have this law: when a number is raised to a power and also raised to another power, the result is that number raised to the product of the powers. Yes. Mathematically, I have x to the power a and also raised to the power b. What is the answer? The answer is x to the power a times b, which is x to the power a b. Okay. When a number is raised to a power and also raised to another power, the result is that number raised to the product of the powers. So I am going to apply this law in the numerator. This is x to the power 2, and this x to the power 2 is also raised to the power 1 over 3. Okay. So what am I going to do? I'm going to multiply this 2 and this 1 by 3. This is also x to the power negative 1 by 2 to the power 3. You multiply the powers. Okay. Another law is also there. When multiplying, so this is the first law that I'm going to use. The second law, when multiplying numbers of the same basis, add the powers. Okay, you add the indices. Okay, so if you have x to the power a times x to the power b, okay, when you multiply numbers of the same basis, you add the indices. So this is the final answer. So you are supposed to recall these laws of indices and apply them. Okay, so let's do the question now. I'm going to erase this part. Okay, so this is x to the power 2 times 1 by 3 times this is x to the power negative 1 by 2 times 3. Everything divided by, this is x to the power negative 1 by 6 times x to the power negative 2 by 3. So this will give me x power negative 1 by 6 plus minus 2 by 3. Okay? Now 2 times 1, this is x to the power 2 divided by 3 times x to the power negative 3 by 2. This is negative 3 by 2 divided by, this is x to the power negative 1 by 6 minus 2 by 3. Okay? From this step, now when multiplying numbers of the same basis, you add the powers. So this is x to the power 2 by 3 plus minus 3 by 2, everything divided by x to the power negative 1 by 6 minus 2 by 3. So if you add this 2 by 3 plus negative 3 by 2, what is the answer? LCM of 3 and 2, this is nothing but 6. 3 into 6. So this will give you x to the power 6. So 3 into 6, this is 2, 2 by 2, this is 4, minus 2 into 6, this is 3 by this one, this is minus 9, everything divided by x divided by 6. This is 1, so this is negative 1. 3 into 6, 3, 6, 2, right? Negative what? 4. Okay. So here we are going to get x to the power negative 5 by 6 divided by x to the power negative 5 by 6. X to the power negative 5 divided by x to the power negative 5. What is the answer? The answer is 1. So this is the final answer for question number 1. Let's move on to question number 2. Let's move on to question number 2. Okay, so this is question number 2. A geometric progression has the first term A, where A is not equal to 0, and a common ratio R, where 0 is less than R, which is less than 1. The sum to infinity of the geometric progression is double the sum of the first 8 terms. Given that the ninth term is 20, calculate the value of R to the power 4, this is 3 months, and B the value of what? Of A. So we have what we call geometric progression, and we have what we call arithmetic progression. Okay. Arithmetic progression is characterized by what? By common difference, right? And here in the geometric progression, we have what we call the common ratio. Okay. This is very important. So they are saying the sum to infinity of the
geometric progression. We know the sum to infinity is, this is the sum to infinity, right? The sum to infinity of the geometric progression is double. So this is equal to 2. This is double the sum of the first 8 terms. Double the sum of the first 8 terms. So the sum to infinity is equal to the sum of the first 8 terms multiplied by 2. Okay. How to find the sum to infinity? The formula to find the sum to infinity. This is A divided by 1 minus R. Okay. A is the first term, R is the common ratio. This is equal to 2. Okay. Open bracket, write A into 1 minus R to the power A over 1 minus R. Okay. This is the formula if you want to find the sum of any terms of a geometric progression. This is the formula. A, open bracket, 1 minus R to the power n, everything divided by 1 minus R. So this is the sum of what of n terms. In this case, I have 8 terms. So I'm going to put in 8 here. Okay. If you check now, here you have A, here you have A. Okay. Here you have 1 minus R, here you have 1 minus R. So you can divide both sides by this. So if you divide both sides by this, what is the answer? You remain with 1 is equal to 2 into 1 minus R to the power 8. Yes, you remain with 1 is equal to 2 into 1 minus R to the power 8. Here we are. We want to find the value of R to the power 4. Dividing both sides by 2, you get 1 by 2 is equal to 1 minus R to the power 8. Make R to the power 8 with the subject of the formula. So in other words, you take this thing to this side. So this is R to the power 8 is equal to 1 minus 1 by 2. Here we are. So R to the power 8 is equal to 1 minus half. What is the answer? This is nothing but half. So in order for you to find R to the power 4, this can be expressed in terms of R to the power 4. This is R to the power 4 to the power what? To the power 2, which is equal to 1 to the power 2. So R to the power 4 to the power 2 is equal to 1 to the power is equal to 1 divided by 2. Here we are. See, if you say 4 multiplied by 2, you are going to get 8. So this is correct. Now we want to find R to the power 4. What do? You find half of this side, half of this side. Okay. In other words, you take the square root of this side. If you take the square root of this side, you are going to remain with R to the power 4. What you do on the left-hand side is something that you're supposed to do on the right-hand side. So this is 1 divided by 2 to the power what? To the power half. This is also to the power half. Okay. Now what is the answer? R to the power 4 is equal to the square root of 1 by 2. So R to the power 4 is equal to root 1, which is nothing but 1 divided by root 1 divided by root 2. Now R to the power 4 is equal to what? This is nothing but 2 by this is nothing but root 2 by 2. This is the final answer. Okay? Root 2 by 2. Let's move on to the next question. What is the exact value of A? You are supposed to find the exact value of A. I'm going to erase this part. Okay? See, if you want to find the value of A is nothing but the first term. So if you want to find the term of a geometric progression, you use N is equal to AR to the power n subtracting 1. Okay? And they are saying we are given the 90th term is given. So U9 is equal to AR to the power 9 subtract 1. U9 is nothing but 20. So 20 is equal to AR to the power what? AR to the power 8. Okay. What is the value of R to the power 8? So this is 20 is equal to A. The value of R to the power 8 is nothing but half. from the previous question, part A, we found that the value of r to the power 8 is nothing but what? Is nothing but half. So A is equal to what? A is equal to 40. If we bring these two to this side, it will be 20 into 2, which is 20. Y varies so this is question number 3. Y varies jointly as the square root of x and inversely as the cube of z. Y is equal to 16 when x is equal to 9 and z is equal to half. Part A, express y in terms of x and z. Part B, find the value of z when y is 2.5 and x is equal to 900. Okay, so this question is coming from variation. We have what we call partial variation. We also have what we call joint variation. We also have what we call direct variation. We also have what we call inverse variation. So these are the 4 types of variation that we have. Okay, so if a question is given, you are supposed to identify the type of variation. In this case, it's joint variation. This is joint variation. Okay. So why this y varies jointly, as the square root of x, as the square root of x, and inversely as the cube of z. So multiplied by 1 divided by z to the power what? To the power 3. This is the thing. So I managed to convert this statement. The first statement, this is the mathematical statement. Okay. Word problem into this is mathematical, right? Now, if we remove this proportionality symbol, we are going to introduce the what? The constant of proportionality. So y is equal to k root of x divided by z to the power 3. If you check, this formula is connecting y, k, x, and z. But the question is saying, express y in terms of x and z. The question is not saying express y in terms of x, z, and the constant k. So you are supposed to find the numerical value of what? Of k. How? You substitute. Y is equal to 60. So y is equal to 60 when x is equal to 9. Root of 9, square root of 9 divided by z is half. So this is half to the power 9. So this is 16 is equal to, if you bring this thing to this side, it will multiply. In this case, half to the power 3 is dividing this thing, right? So if you bring this half to the power 3 to this side, it will multiply. So half multiplied by 1 to the power 2 to the power 1 divided by 2 to the power 3 is equal to k. What is the square root of 9? The square root of 9 is nothing but 3, right? This is 16 times 1 divided by 2 to the power 3. The answer is 1 by 8 is equal to k multiplied by 3. Here 1. Here what is the answer? This is 2. So 2 is equal to 3k. So what is the value of k? K is equal to 2 by 3. So now y is equal to, what is the value of k? 2 by 3. So 2 root of x divided by 3z cubed. This is the formula connecting y, x, and z. This is y in terms of x and z. Let's move on to question B, part B. Part B is 7. Find the value of z when y is equal to 2.5 and x is 900. So you substitute. Y is 2.5 and x is 900. You want to find the value of z. Or before you substitute, you can make z be the subject of the what? Of the formula. So if you want to make z be the subject of the formula, what are you supposed to do? You take this denominator and multiply this what? This y. So this would be 3y z to the power 3 is equal to 2 root of what? Root of x. Now make z cubed to be the subject of the formula. Z cubed is equal to 2 root of x divided by 3y. Okay, you can substitute here. This is 2 into the square root of x. X is nothing but 900 divided by 3 times y is nothing but 2,5. Okay, this is equal to 2 times, what is the square root of 900? The square root of 900 is nothing but 30. Okay, divided by 3 into 2,5. Okay, now 3 here 1, 3 here 1, 3 here 0. So 2 times 10, this is 20. 20 divided by 2,5. So z cubed is equal to 20 divided by 2,5. So what is the answer? 20 divided by 2,5. This is 8. So z to the power 3 is equal to 8. Now you want to find the value of z, right? So in order for you to find the value of z, you multiply this power by 1 over 3. The thing that you do on the left hand side, you're supposed to do it on the what? On the right hand side. So in other words, you take the cube, the 1/3 of the left hand side and what? On the right hand side. So z is equal to 8 to the power 1 over 3. Okay, so z is equal to 2. This is the final answer. We say express 3 minus x minus 6x squared divided by 1 minus x 2 plus x and 1 plus 2x. This is 5 marks in partial fractions. You are supposed to express this in partial what? In partial fractions. Yes. 3 minus x minus 6x squared divided by 1 minus x 2 plus x then 1 plus 2x. This is 5 marks. So see, we have what we call linear factor approach. We also have what we call quadratic factor approach. We also have what we call improper factor approach. We also have what we call a repeated factor approach. Okay, factor approach. We are going to discuss all these things. Okay. So the thing is this: if you want to express any given expression in partial fractions, what are you supposed to do? You check for improper first. Okay, how do you see this is improper or it's not improper? If you check in the numerator, the highest power of the unknown. In the numerator, the unknown is x. Again, in the denominator, the unknown is x. The highest power of the unknown in the numerator is 2, right? And the highest power of the unknown in the denominator is nothing but 3. If you expand this, you get a cubic function. Okay, so the highest power here is 2 and the highest power here is 3. 2 divided by 3, this is a proper fraction. This is a proper fraction. So there is no need to go for what? There is no need to go for improper factor approach. We factored out improper factor approach. Now I have linear factor approach, quadratic factor approach, and repeated factor approach. Repeated factor approach is characterized by like you have a linear factor now, and this a linear factor is raised to a power. Then we'll be talking about what? We'll be talking of a repeated factor approach. For example, let's say I have 5x plus 2 divided by 3x plus 7 to the power 2. If you check, this is a linear factor, and this linear factor is raised to a power. Then you start talking about a repeated factor approach. So in this case, there is no repeated factor. We cannot make use of repeated factor approach. Let's check on the issue of quadratic. You know what is a quadratic function, a quadratic equation. You know a quadratic expression is characterized by what? The highest power of the unknown is what? Is 2. For example, let's say you have a factor in the denominator which is like this, ax plus b. Okay, like let's say this is the thing. Then here I can say 3x squared plus 7. Okay, so here you'll be talking of the quadratic factor approach and repeated factor approach, because this is a linear with the power, so it's repeated. Here I have a quadratic in the denominator. Then I'll be talking about quadratic factor approach. In this case, we don't have a quadratic expression or quadratic factor. So this is the remaining part, linear factor approach. So we are supposed to use the linear factor approach. So 3 minus x squared divided by 1 minus x into 2 plus x into 1 plus 2x is equal to a divided by 1 minus x plus b divided by 2 plus x plus c divided by 1 plus 2x. The LCM, you multiply all the terms by the LCM. This is the LCM. So if you multiply this by this, you will remain with 3 minus x minus 6x squared is equal to a into. If you multiply this by this, here you will remain with 2 plus x and 1 plus 2x. Okay, here this is the term multiplied by the denominator. So this is plus b into 1 minus x, 1 plus 2x plus c into this. By this you remain with 1 minus x, then 2 plus what? Plus x. Okay, here we are. So we use the cover up method, right? You can make use of the cover up method when x is equal to minus 2. When x is equal to minus 2, so here it becomes 3 minus 2 minus 6 minus 2 squared, okay, is equal to, here if you put minus 2 plus 2 is 0, so this will become 0. Here again you are going to get a 0, so you will remain with b. So this is equal to b minus 2, so b minus b into 1 minus 2. This is very important. This is 1 minus 2 into 1 plus 2 into minus 2 like this. Okay. So I'm going to use my calculator to find the answer for this side. So this is 3 plus 2 minus 6 minus 2 to the minus, this is 3 plus 2 minus 6 into 4. So this is negative 19 is equal to 1 minus 2. This is 1 plus 2. So this is 3 into 2 minus 2. What is the answer? This is minus 4. 1 minus 4. What is the answer? This is minus 3. So you get minus 19. So minus 9. So this is b into minus 9. So in order for you to find the value of b here, you divide both sides by negative 9. So b is equal to minus 19 by minus 9, which is equal to 19 by 9. So this is the value of b. So b is equal to 19 by 9. Let's move on to the next part. Here I am going to say when x is equal to 1, when
x is equal to 1. So this is 3 minus 1 minus 6 into 1 to the power 2 is equal to, this will become 0, this will become 0. So this is a 2 plus 1, this is 1 plus 2 into 1 like this, okay. So this is 3, okay, minus 1 minus 6. What is the answer? This is minus 4 is equal to a 2 plus 1, this is 3. 2 here plus 1, this is 2 here. 2 into 1, this is 2 plus 1, this is 3. So 3 times 3, you get a 9. Okay. So what is the value of a? A is equal to minus 4 divided by 9, which is equal to minus 4 by 9. Okay, this is the value of what? Of a. Let's move on to the next part. Now when x is equal to what? This is the thing, right? We want to find the value of x here, which makes this part be equal to 0. So when x is equal to minus half, when x is equal to minus half. So 3 minus half minus 6 into minus half to the power 2 is equal to, this will give a 0, this will give a 0, c into 1 minus half, okay, open bracket 2 minus half, here we have. Now, this is 3 plus half minus 6 into 1 by 4, okay, to the power 2 is equal, so this is 3 plus half minus 6 to the power, so here I think I made a mistake. Okay, this is 3 plus half minus 6 into 1 by 4. So this is 2. So 2 is equal to, this is 1 plus half. Okay, 3 by 2 multiplied by 2 minus half. Okay, you get 9 by 4c. 9 by 4c. Okay, now what is the value of c? C is equal to 2 times 4 divided by 2 times 4 divided by 9, which is equal to 8 by 9. So this is the value of C. Okay. Now this expression in partial fraction is given, right? A is negative 4 by 9. Okay, so this is negative 4 by 9 in bracket 1 minus x. B is 19 by 9 plus 19 by 9 2 plus x. Okay, plus C is 8 by 9 into 1 plus 2x. This is the final answer. Let me check. Okay, let's move on to question number 5. Question number 5. I'll confirm this question number 4. It seems as if I made a mistake somehow. This is negative 4 by 9 of 1 minus x plus 19 by 9 into 2 plus x plus 8 by 9, 1 plus 2x. Okay. Let's move on to question number 5. Given that power 3 plus ax plus 3 is divisible by x squared minus x plus 1, where x is not equal to 0. Find the value of a. This is 4 max. B. Hence, factorize x completely. Factorize f of x completely. Okay. So it is given that the polynomial h of x is equal to x to the power 4 plus 3x to the power 3 plus ax plus 3 is divisible by this, where this is not equal to 0. Find the value of a. C. This is the polynomial and it is divisible by this. So h of x is divisible by x squared minus x plus 1. So if you are saying this is divisible by this, it means this is a factor of h of x. In other words, x squared minus x plus 1 goes into h of x and does not leave a remainder. Right? It does not leave a remainder. So what is the answer? The answer is also in terms of x. I'm going to represent it using q of what? Of x. Okay? See, this is actually this is a quadratic expression, right? So if you multiply this and this, you are supposed to get h of x. So h of x is equal to x squared minus x plus 1 into q of what? Of x. The highest power of the unknown in h of x is 4. Okay. So here it means you should have a quadratic function again, in such a way that if you multiply x to the power 2 and x to the power 2 of q of x, you are going to get x to the power what? You are going to get x to the power 4. So I'm going to represent this using a quadratic function. This is h of x is equal to x squared minus x plus 1. Okay, here I'm going to say b of x squared plus c of x plus d. Why I didn't say ax squared? I didn't say ax squared because here h of x, a is there, and I want to find the value of this a. So let's multiply this together. Let's multiply this together. This is x squared times this one. This is bx to the power 4 plus cx to the power 3 plus this is dx what? Dx squared. This is minus bx cubed. This is minus cx squared. This is negative xd. Here 1 into this. So this is plus bx squared plus cx plus d. Here we are. Let's check now. Let's check together. You compare. H of x is equal to this. Okay. If this is negative, h of x is equal to this. Now the coefficient of x is a. So a is equal to. Here, what is the coefficient of a? Want to find out the coefficient of x. Here x4, x3, x2, x3, x2. Here I have negative d. So this is equal to, this is negative d. This is x squared, this is plus c. Okay, plus c. Here we are. Here we also have d is constant. Okay, this is the thing. So we are supposed to find the value of d and c now. Okay, let's check here. The coefficient of x to the power 4. Here the coefficient of x to the power 4 is 1. Okay, here the coefficient of x to the power 4, we only have b. So b is equal to 1. Okay? The coefficients of x to the power 3. Here I have c. Okay? This is c. This is negative b. Here I have c. This
x to the power 3, x to the power 3, x to the power 3. So this is equal to what? This is equal to 3. But b is 1. So c minus 1 is equal to 3. So c is equal to what? To 4. Okay, so now I have the value of c. Let's check the constants. x4, x3, x2, x3, x2, x squared. So I have d. D is the constant. So d is equal to what? D is equal to 3. So now a is equal to minus 3 plus 4. What is the answer? A is equal to 1. So this is the final answer. Okay, boys and girls, I'll see you in the next class. So please kindly subscribe to my videos in order for you to see all the question papers that I'm going to upload. Thank you very much.